All right, ladies and gentlemen, welcome back. Many of us still need to sign up for Big Ideas Math. Go to Canvas and make sure you follow the directions exactly as they're written on Canvas. You will also need a graphing calculator for this class. Don't forget that. You'll need it for Algebra 3. Hopefully you got it. Hopefully you still have it from the spring, because we did not turn those in. So if you rented one from the school, you should still have it. If you don't and you lost it, that's going to be a problem. But you'll need a graphing calculator, and somebody had told me that you can go online and you can get a free trial for 90 days of a graphing calculator on your device. And the Desmos, I think, is on the BIM, Big Ideas Math, can also give you a graphing calculator, I believe. Alright, so today we are going to talk about translations and reflections of functions. So my first example, and we did this a little bit yesterday, or yesterday's problems. We have f of x is equal to 4x minus 9. And I want to write a new function that just comes and gives me a vertical shift of 5 units. Okay? And I'm going to go up. I just want a new function of that. So I'm going to call that g of x. It has a different name because it's a different function. So I have 4x minus 9. Let me do it this way. Maybe some of you will see it easier if I say this. So g of x is going to give me that original function f of x, and then we're going to add 5 to that because we're going up, so it goes with the sign. So this is equal to my f of x, we've already said, is 4x minus 9. Now we have the plus 5. So this is equal to 4x minus 4. So g of x, my new function with a translation of 5 units up, gives you 4x minus 4. Alright, I'm going to use the same function. And this time I'm going to reflect it, I'm going to translate this 1 unit to the right. So I'm going to go to the right 1 unit. Now, since we're going left or right, remember that that goes with the x. Left or right is the same as the x-axis. So I have to go 4, and inside that parentheses, I have to have the x. And so we're going to the right, I have to have the opposite sign, x minus 1 minus 9. Again, it's going left or right, you have to put in the parentheses. Since it's going to the right, I need the opposite sign. Now distribute, this becomes 4x minus 4 minus 9, which is equal to 4x minus 13. Easy enough, I hope. Stop the video whenever you need to and go back and review it. I strongly suggest that you do that. Alright, my example, I believe this should be example number 3. We're going to talk about a reflection. And a reflection, we're only going to talk about reflections above the x-axis. And we've already talked about that. If I have a positive quadratic, it's going to look that way. If I reflect it about the x-axis, it's going to look this way. It's not drawn to scale, but you know what I'm saying. Okay, so we're going to have my function f of x is equal to the absolute value of x minus 5 minus 4. Uh-oh, let me make sure my camera's okay. I've done it before where I really messed up. I hope you guys were able to see that last problem in its entirety. If not, you can go back and listen to everything, because I pretty much explained everything we did. Alright, so I want to reflect this guy. Reflect, there's an L in there. Reflect about the x-axis. We're not going to do the y-axis. You can do a reflection about the y-axis as well, but we're not going to do that. We're just going to worry about the x-axis. So if I'm going to go about the x-axis, so g of x is equal to, if it's positive it opens up, so negative f of x. Because whenever your a is negative, that's when it will reflect it. So g of x then is equal to the negative, I'll put this in parentheses, my f of x is x minus 5, the absolute value of x minus 5, minus 4. All I need to do now is distribute this negative 1. Remember, inside that absolute value, you can think of these as a jail cell. Nobody can come in and nobody can go out of these bars here. So you cannot distribute that negative inside the absolute value. It just comes on the outside. Negative absolute value of x minus 5, and distribute it here, so that becomes plus 4. That is my new function with I have a reflection about that x-axis. Negative absolute value of x minus 5 plus 4. Alright? So right. Now then, let's do example number 4. And that is going to be f of x is equal to the absolute value of x plus 3 plus 1. And again, we want to reflect that about the x-axis, so g of x is equal to the negative f of x. So this is equal to the negative absolute value of x plus 3 plus 1. So that's equal to the negative absolute value of x plus 3 minus 1. And there you go. I'm going to leave that right there and upload this video, and then we'll do another one here in a bit, again, because YouTube does not like too long videos for whatever reason. See you in a bit.